Hello, welcome back. Let's continue with the solid principles. We covered 3 of 5. Now we have 2 to continue. Which one is the next? Liskov substitution principle, I think.
Yes, the one with the scary name.
Yes, always very confusing.
Yeah, so like, if I remember correctly, it's basically that subclasses should behave as valid instances of a parent class, right?
I think it was like a couple of really very exceptional cases where I did have to care about this and use it in the reasoning, honestly, about substitution.
Yeah.
Basically, that was, yes, indeed something about that, okay, you should not care if you accept the interface, like some interface, you should not care what implementation you are using, basically. You should not do if instance this, if some instance that, and so on. That's about the nice design of the nice object-oriented design.
And I think the one time I read up on this was when my friend Jan Auwes, who created equals verifier. So for verifying implementations of equals methods, it comes into play. But I can't really remember how exactly.
That's quite, I think, edge case. I think what the gripe here, if I understand correctly from then I share it, is more about being too much or object oriented, in a sense, using in the modern code too much as of is a, x as a, sometimes can be used, and so on. And that I definitely, so that would be a little bit of a smell to me, generally speaking, in pragmatic development.
Because it's basically UML based programming.
Yeah, something like that. But yeah, so I agree that that's probably not the most important principle, especially if, in the modern development.
Yeah,
it's a sensible thing, especially if you're working with the hierarchies. I would say I try to use as little as the class hierarchies as possible.
Yeah, agree.
Because they tend to complicate things, really. And rarely in the long run the benefit outweighs the complexities.
Yeah.
So I would always try to reason for aggregation, to just passing two things separately instead of trying to hide the differences. And most of the time it's easier to reason, it's obvious what's happening, and just better.
Yeah.
But if you do have a good case for object-oriented, then of course Liskov substitution is something to follow, although most of the times good experienced developers will follow it naturally, I guess.
Yeah, and maybe this is one of those cases that also is more relevant if you're making libraries.
Well, that would definitely be more relevant, of course, when you're making libraries. If you have some kind of hierarchies and you don't follow, that would be very surprising to your consumers.
Yeah, exactly.
Because if something is such surprising to me in my code, at least I can relatively easily fix it, hopefully.
Yeah.
Easier than with a library.
Yeah, definitely. Well, you just make a merge request, right?
Yeah. And update a bunch of versions. And make sure that it's not backwards. Keep up with the backwards compatibility. And hope that no one relied on this particular behavior and cries that we ruined his universe.
Wait, are you saying there's more to coding than just pushing it to the branch?
Anyways, okay. I think this doesn't seem to be a very strong point, so we probably don't necessarily have to vote.
Yeah,
it's sensible.
I think it's one of those things that matter quite strongly if you want to argue theory, but don't really come into play so often in practice.
When it comes to play, then it can be nasty. Let me put it this way. When it comes to play and it's nasty, it's difficult to argue on the level of theory. Because usually you say, okay, it's just, look, I'm just here, I need to make always the judgment whether this class or not.
But then if you do argue with the Liskov substitution principle, people are going to think you are awesome.
they will think that I'm an awesome asshole. That's what they will think.
That's true. That's true. That's true. It's kind of like using a word like serendipitous in a sentence. It's like, hey, you used that actually in a place where it made sense. Good on you.
Yes.
Can we?
But I think actually that's one of the problems with these principles when people are starting to hide behind these principles and just say, okay, this is Liskov, you should not be. And sometimes it becomes very difficult to argue because of that. Because at the end there are reasons and validation. But he says you are violating this. That's just no go.
Yeah.
And then it becomes like this dogmatic approach. Then they can be very dangerous.
Yeah.
And I think that's the biggest danger and the biggest harm of these principles when they are misapplied.
And I think it's also the biggest message of this blog post in general, that being dogmatic about principles is destructive.
Yeah. Everything is in the context.
Yeah, exactly. And he shows that very well, that these old principles are now outdated principles for quite a few. And that makes total sense because the world changes.
Yes, absolutely. Okay, let's move on to the next one.
Yes.
Dependency inversion.
Principle.
Would you like to kick it off?
Yeah. I think this is a fun one because I love the dependency inversion. I think it's a really good concept for writing understandable, testable code. I also really understand the hate it's been getting because people have been calling dependency inversion frameworks as if they are what dependency inversion is. And I think it's very easy to do. Well, it's not very easy, but it's very it's not that hard actually.
It's easy enough.
Yeah, it's easy enough to do dependency inversion without any framework whatsoever, and you will get the benefits without a framework. But on the other hand, if a framework solves this well for me, then I also happily will use the framework.
Yes, and I don't think that then argues too much about the fact that you're using that there is a dependency inversion.
No, I think
it's more about the nasty side effects sometimes.
Mm-hmm.
Yes, and sometimes these frameworks, they can be a little bit on the heavy side. So I have a mixed feelings, for example, about Spring in this case. He mentions this also one of the examples when you start to rely too much on these frameworks. And on one hand, I absolutely agree with you. It's just so convenient, and I like this convenience that I mark something with a component, I drop it into my context or whichever other way I'm using in my injection framework. I'm dropping it, and it appears available for everything else, and I can go where I want to use it. Say, okay, now inject this thing, and it's here, and I don't have to manually add this path how it gets there. So in this way it's very convenient, and I will be still probably using. But there are some downsides. I think there are two downsides I can talk about. The first one is this convenience often comes at the cost. Like in our all discussions with the testing and the quality of the test setups, with Spring particularly, often the price of setting up the dependencies bites us back if you're not very careful. And that comes, as far as I can say, mostly through the convenience of class scanning and things like that. So that's something also not that completely without side effects. Again, you can work this around even with in Spring by explicitly specifying your dependencies and so on. That's one side. Another thing that I don't like about all abuse of dependency injection when too many things are starting to get injected, just because everything is just a dependency. And then you're starting, okay, there is one thing, it's about when we're starting to go into interfaces always extracted, but even without the interfaces, you have a simple dependency, which can be just a static function, for example, something, and suddenly you're starting to inject it. Well, that's often makes things complicated, and it drives to unnecessary mocking things, because by default, again, you will start mock those dependencies where just could have been just a static call.
Yeah.
I think in Kotlin we're starting to get into interesting situation, because in Kotlin, for example, propagates the use of functions like a first class without classes or objects, and then you often see people struggling with this. What is more idiomatic? Not shall I stay with the idiomatic Spring injection things, or more idiomatic Kotlin and just calling this object directly in function?
Yeah.
But that's a little bit of sidetrack. And the third thing, probably where you will jump in is the extraction of the interfaces, where you have just one reasonable implementation in your code base.
Yeah, I think that's one of the parts of the dependency inversion pattern that is pervasive and goes wrong a lot. That there is this need to provide an interface for everything so that you can change the underlying implementation separate from its use cases. It's in a microservice world. I just don't think that is a smart move, since the whole code base is usually within the control of this one team. So modifying it for a new case is much more future-proof than trying to set up a architecture that all kinds of possible new cases can be bolted onto later. So
yeah,
I really think that's a pattern that has no place in a microservice architecture.
By default.
By default.
Yes.
Yes,
By default,
yes,
no.
by default. Yeah.
Yeah, I agree on that. There used to be some technical reasons for this. For example, in the first versions of Spring, you would use interfaces because otherwise you would not be able, or with earlier versions of the mocking libraries, you wouldn't be able to easily mock something.
Oh.
Nowadays, this is not a problem. Modern mocking libraries, if you do want to mock, I prefer not, but if you do want to mock,
yeah,
they are working perfectly fine with just normal classes and mocking them fine. So this is not a reason anymore. The only other reason I still see is if you don't want to mock but still don't want to use the real thing, and you want to provide a fake implementation, simplistic implementations, then it starts to make sense to have an interface in implementation.
Yeah, especially if you do something like hexagonal design that separates your dependencies from your domain. Then that makes a lot of sense. But to me, that is like a now need for an interface, and I think a now need for an interface is always a good reason, and a future need for an interface
absolutely
is a lot less often a good reason.
Yeah, I know another small reason why people extract the interfaces, because they find that this way they can describe better the behavior of the class. It's especially those who are coming with a C background. I remember when I was switching from C to Java, I really miss the fact that I have a header with a specification and then the details of the implementation. But well, in Java we usually do this mixed. So.
Yeah, so you mean that you can specify it separately from implementation? Yeah,
well, that's what usually how you often do that. With the public classes, you would specify it in the header.
Yeah.
Maybe I was not very strong developer in C++, so maybe it was not necessarily necessary, but I was doing that always, and I found it because you would have very clean, without a need to use your shortcuts of IntelliJ or whatever you're using. You would have a clean interface, saying, okay, this is my interface, and then you go to your implementation, and then it is it.
Yeah, to be honest, what I do quite often when I develop slightly more complex things myself is that I program something against an interface, and then later when I implement that interface, I delete the interface. So I use the interface to define its interface, and then I'll implement it, and I find that there's only one implementation, and I'll just, I then switch over to the actual implementation.
Yeah, that's interesting, because that's... In Java, I would also do it like that, but in Kotlin, you can just have a class already with the message that you want, and there you just type to do, which makes your code compiling, and things are working.
Yeah.
But okay, I don't know whether it would cover completely.
Yeah, I don't even remember whether this was in Kotlin or Java the other time. There was one more thing that I wanted to hook onto that you said earlier about injecting static methods, essentially. I think, to me, the one static method call that should almost always be abstracted away into a dependency is a static method call that relies on state.
Okay, that one, of course, if we're talking about state, that's a completely different story.
Yeah,
so
and
here
like
I'm talking about functionality. I'm talking most in the context of functionality. If you're starting to talk about state, that's a different. And we're talking about the state within your
the
code, not something in the database or something else. But or do you also mean the database?
The seminal example here is the clock, I think.
Yeah. Okay. The clock is it a state? Okay, I would not normally think of clock as a state, and I thought you would be pointing to the clock. Okay, the clock is a good example. I think you want to be able to override it for the stability purposes, always.
Exactly.
And there are different ways how you do that. I prefer personally just to have explicit parameter with the time now and things like that.
Right, yeah.
You might prefer to use clock service or something like that, which is also fine as long as it is providable. But that's, yes, I agree on that. You want to have those things to be inversed.
Yeah, exactly.
Most of the time. Otherwise, well, it's just from the practical reasons. Otherwise, it's too difficult to test, difficult to reason to.
Yeah, exactly. But I'm curious why that doesn't map for you as a dependency that's dependent on state.
Yeah, well, because it's outside of our. It's like for me, it's environment. But it's clock is still coming from outside. It's more like a side effect, but not our side effect, but something that comes to us from the environment. It's something like also if I'm calling external method, yes, it's external state.
Yeah.
But that's and that's what you often want to have explicitly be swappable. Yes, that's why. Yeah, to me it's
okay.
I think, but we often think about this as something internal, but it's time is external.
Yeah, exactly. All right. So I kind of lost track here. I think we
did the second one. I think we are done with the dependency inversions principle. So
definitely.
I guess we are more or less together with Dan here, and we're adding 2 points in favor of Dan here, right?
Yeah, definitely. So basically, conclusion is that we think that he knocked it out of the park. And I'm very curious to see what his CUPID rules are going to be.
Clean, user-friendly.
Perfect.
To the point.
To the point. Idiomatic.
Igniting.
Oh. Or...
and definite.
Should definitely be definite. Yes. I agree.
Well, it should be somewhere. It should have somewhere something about measure. Does it fit in my head? But I don't see which one of those will be. It should measure that.
Inside my head with an eye.
Yeah, CUPID. I don't know, but it should. There should somewhere be fits in my head. One of the principles.
Yeah,
definitely.
Though that was actually the one thing I disagreed with.
Yeah, that's good. We will have something to disagree on when discussing the CUPID principles.
Excellent. Yeah, let's do that. All right. So, thanks a lot, and we'll send this out and let us know what you think of the solid principles, of Dan's judgment of the solid principles, and of our consideration of his judgment of the solid principle. Bye bye.